In this example, we will determine the domain and range of the following functions. We have two functions f and g. F of x is equal to negative x minus 3 quantity squared plus 11, and g of x is equal to 1/3 x plus 2 quantity squared minus 7. Okay, so the first thing I notice about both of these functions is that they're both quadratic functions given in vertex form. So I can easily state what the vertex of each of these things happens to be. Now, I don't necessarily need the vertex, but I need the vertex to determine the range at least. But before we talk about the range, let's talk about domain for a moment. So remember that the domain is the set of all values of x in which we get a real value output for y, right? So there are no variables in denominators or under even roots or anything that would cause trouble in terms of limiting the domain. So unless you have an application problem or the problem somehow states that the domain is limited in some way, for all quadratic functions, the domain will be all real numbers. So I'm going to say negative infinity to infinity. And I might as well write that in for both of these examples right now because that's just something that we know about quadratic functions, right? For any input x, real input x, we're going to get out a real output for y. So now let's talk about the range. The range is the set of all possible y values. And because these are quadratic functions, we know that the graphs will be parabolic, right? Which means that they'll carry a minimum or a maximum, right? They're either going to open up like so or down like this, right? So they're either going to have a minimum y value or a maximum y value. And so the question is, well, how do you know which is which, right? Whether it opens up or down. Now, one way, of course, is you could just go to Desmos and graph these, right? But there's actually a way to tell just looking at the formula which is which. And this is what we're looking for. Look at the value of a, the leading coefficient. So for f of x, a is equal to -1, right? And that means that it's less than 0. When a is less than 0, we know that the parabola opens down because the graph of x squared has been reflected in the x-axis. So all of the y values become negative before it's shifted all around left and right and whatnot. So if the value of a is negative, we know that the parabola opens down and we have a maximum y value. Well, what is this vertex point, right? Do we know what it is? Well, it's 311, right? Since this is in vertex form, we've learned that. So if the maximum value is 11, then the range will be negative infinity to 11, and I'm including 11, right? So by contrast, g of x has a positive value for a, right? That leading coefficient is 1/3. So since a is greater than 0, that means the parabola opens up, right? So the minimum point, what's the vertex here? It's going to be -2, -7. Now for the range, we care not about the x value, but we know that the minimum y value is -7, right? So we know that we will have all values from -7 to positive infinity. And again, I'm including -7 in the range because it's included on the graph, right? We can never include infinity or negative infinity in an interval because we can't actually get there. So make sure you use an open bracket with that. Okay.